everyone. Today we shall be discussing the modified bilobed flap, which is used for BCS and breast reconstruction. Now if we look at the history, it all started with ASAR in the year long back 1918. After that, Jimani modified the flap with the use of smaller lobes, allowing a more aesthetic closure, right? Then finally in the year 1989, Jitelli modified the flap to reduce the rotational arc from 90 degree to 110 degree, which is the most common modification used today, right? So now we will discuss the marking. The first of all, what happens usually in bilobed flap, the defect we make as a circular defect. So this is the defect. Now what happens, how do we measure or how do you plan modified bilobed flap? So it has got a center. From the center, this distance and this distance. So it's a C, D, A, or this is B, right? So this center, this is the radius R. So you have to draw another center, another pivot. This is called P point, which is equivalent to R. So CB is equivalent to BP. This is the P. So this will be the center of the future pivot. Okay. Now there will be two circles. One is an outer circle, another one is inner circle, right? So this outer circle is taken with a diameter, with an radius of 3R. So this is 3R, right? Now inner cycle has got a radius of 2R. So these two are outer circle, inner circle, right? Inner circle. Now from the edge of this circle, another circle will be drawn with a radius of usually R. Okay. Now this angle between these two is usually kept at 45 to 90 degree. Initially it started with 90 degree, then it dropped down to 45 degree. So that has got a wider benefit if we go for a smaller angle. Okay. So this is the tumor or defect. This is the lobe 1. Now this one will go here. Now from the second one, that is from the L1, we draw another circle with a radius less than equal to R. So this is less than equal to R. So this is the conventional. Again, this angulation is between 45 degree to 90 degree, right? So this is the conventional way of making a bilobed flap. Okay. So now this L1 will cover the tumor defect. L2, this is L2, lobe 2 will cover this defect. Okay. Now after this L1 goes here, there will be a standing cone defect or standing cone deformity which will be there in this triangle, and you have to excise this triangle. Sometimes if we can make a triangle beforehand, then this can be adjusted. Okay. So this is how a bilobed flap works. Now what happens, the modification from 90 degree. So this is the first one, this is the center, this is the outer circle, this are more or less same. If this is R, then this is R. So this first one, initially it was, the first low was this angulation was 90 degree, it was brought down to 45 degree. Now this is one modification. Another modification is when we take this outer and the L1, we can enlarge this towards the outer to the tune of 10 to 20%. This is allowed. Okay. Now the modification which we have done by supercharging, again the same modification can be done with the L2. So you can enlarge it and you can make it a triangle so that you close it primarily. After you move the L2 to L1, then you can close it primarily. Now this closure is facilitated by a simple closure if it is a triangle. Sometimes what happens, if this angulation between this and this, if it is more than 90 degree, then there is a chance of less vascularity in the pivot. There, if we can supercharge this area with some other vessels, then the survival of the flap increases, and this modification is done with the use of lateral thoracic perforator, right? Lateral thoracic artery perforator. So this is supercharging of the L2. Okay. Now let's look at this lesion, which where this is the tumor defect. Okay. So what options we have? We can go for a round block. Yes. We can go for a matrix rotation. And we have another option of going for a bilobed flap. So after we excise this area, this is going to be the defect, circular defect, more or less circular defect. You see this triangulation which we have done is intentionally made like this. Now this is the center. So if this is R, then we will have, this is the pivot point, right? So this one is R, this one is R, this one is R. Now the outer circle is this one, this is 3R, this is 3R, and inner circle is this one. Okay. Now the first original, as per the original recommendation, you take a like this. So the modification which we have done here, we have increased this to 10 to 20%. Okay. Now see the angulation between these two. This is less than 45 degree even. Okay. So that serves the purpose. But with this one, see here, this increase is more than 20%. So that modification means that tip will require some sort of blood supply, and that's what we have done with this. Not only that, this angulation is little bit more in comparison to the standard bilobed flap. So here the addition of these two, this vascular supply is really going to be helpful. Okay. So that's the modification, that's the marking. Now this is the cut we are making. This is the primary side area being removed, and this is the first cut we are making. Okay. And that's the next cut. So supercharging is based on the LTAP, right? So if you see, that's the first one and this is the second one, and supercharging is based on this LTAP. Now the L2 is being covered, is supercharged with the first one with LTAP. So that is the modification which we have done with the LTAP vessels. Now regarding the nipple traction and etc., if we make the circle towards the nipple and the L1 is bigger than the tumor defect, then we will always have a less chance of traction of the nipple. So it is a dictum that you make the L1 more than the tumor defect and L2 is more than the L1. So these complications can be avoided. So hope this was useful. Thank you very much.